Welcome everyone. In this video lecture, we will solve a question on MOSFET circuit at DC. So in the question, an enhancement type NMOS transistor with threshold voltage VT 0.7 volt is given, has a source terminal grounded and a 1.5 volt DC applied to the gate. Okay, so in what region does the device operate? Either linear, saturation or cutoff for different drain voltage VD 0.5 volt, VD 0.9 volt and VD 3 volt. So the question is, there is a NMOS, okay, enhancement type NMOS transistor. Okay, so I'm just making it enhancement type NMOS transistor. It will better to make a broken line. Okay, this one is source terminal, this one is our gate, drain terminal and source terminal. Okay, so in the question it is given the VT value is 0.7 volt and source terminal grounded, that is our Vs is grounded, so we can make it, okay, we can make it ground, that is our Vs is 0, okay, and Vg is 1.5 volt, okay, and this Vd is given zero point 0.5 volt first one, for zero point 0.9 volt another one, and 3 volt. Okay, three things are there. For VD zero point 0.5 volt we have to find in which region it will operate. Okay, so this one is the question. So before that, I want to again going to redraw the ID VDS curve. Okay, ID in milliampere, VDS in volt, we can make it in milliampere. Okay, if we plot the ID VDS curve, it will somehow like this. Okay, and this point is our VGS minus VT. Okay, so in this side this would be in saturation. Okay, saturation, and this side is in the linear region. Okay, up to this it is in the linear, so this one is also important. Okay, so now there are the condition for the saturation region, the VDS should be greater than equals to VGS minus VT. This one is the condition for the saturation region, and VDS should be less than or less than VGS minus VT, will be in the linear, or sometimes it is a triode region. Okay, so these two conditions we have to know. So in the question it is given VG value is 1.5 volt, source potential is 0, and this VD is different value 0.5, 0.9, and for 3 volt we have to find in which region it will operate. So we have to start with a for VD 0.5 volt. So the first of all, you find VDS. Okay, so VD minus VS, VDS 0.5 minus VS is grounded. So simply we can say here Vs equals to 0. So VDS value will be 0.5 volt. Okay, now we have to find VGS minus VT. Okay, so it should be written VG minus VS minus VT. VG minus VS. Okay, VS is grounded and VG is, okay, also I am writing here VG is 1.5 volt. This clearly mentioned VG is 1.5 volt. Okay, so we can also write here also 1.5 volt. Okay, so 1.5 volt minus 0, Vs is grounded, so 0, minus Vt 0.7 volt, so its value will be 0.8 volt. So Vgs minus Vt will be 0.8 volt. Okay, so once again I am just highlighting. This one is given VD 0.5 volt, VS grounded, VG 1.5. So first find VDS. Okay, so after solving, VDS is coming 0.5 volt because VS is grounded and 0 VD is 0. Then VGS minus VT, VG minus VS, VG is 1.5 minus 0, minus, it should be 0.8. So now what we have concluded from this one, this VDS is less than VGS minus VT. Okay, from this one, say I am saying this one is a equation 1 and 2. Okay, so we can write VDS is less than, okay, VGS minus VT, because this one is VDS is 0.5 volt, this 0.5 volt is obviously less. So this one is the condition. So this one is basically in the triode region, triode, or sometimes it is say linear, 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 okay, region. Okay, so this one is in the linear region. Okay, the first one, for the first one, for this value it is in the triode region. Okay, so first we have already calculated. Now for the VD value 0.9. Okay, so for VD value 0.9 volt, VS will be grounded, no need to change, 1.5 volt. So now VDS, first we have to find the VDS. So here VDS will be 0.9 volt because VD minus VS. Okay, this one is VD minus VS. VS is grounded 2.9, so simply 0.9 volt. So VDS is our 0.9 volt. Okay, and VGS minus VT we have already calculated, so no need to calculate every time. So now here we can easily say this VDS will be greater than equals to VGS minus VT, because this VDS is 0.9, okay, volt, and this will be 0.8 volt. So this one is obviously greater, so it will come under this region. So we can say for this one, okay, for this, okay, I am taking different color. Okay, for this condition VDS is 0.9 and this one is 0.8, so 0.9 volt is greater than this one. So this is the saturation region. The device will be operate in the saturation region. For this one, it is in the saturation region. Okay, very simple, but we have to know the this one. Okay, clear? Because this VGS is already calculated, VGS minus VT. So the thing is that VGS minus VT is already 0.84, so no need to change. So now we have to go for the third point for VD 3 volt. For VD 3 volt, okay, all will be same. VS 0, okay, VG 1.5 volt, VT is also given, threshold voltage 0.7 volt. Okay, no need to write every time, but we can write. So VDS we can write VD minus VS. VD is 3, source potential 0, so this one is 3 volt. So here VDS is 3 volt. Okay, now VGS minus VT, no need to calculate because you already calculated, or if you want to write, then write like this: VG minus VS. VG is 1.5 minus 0 minus 0.7, 0.8 volt. So VGS minus VT is always 0.8 volt in our case. So now for this condition, okay, VDS is 0.5 and this one will be, okay. So which one is greater? VDS is obviously greater than, okay, VDS is greater. So what we can write? Okay, I have to select VDS is greater than VGS minus VT, because this one is 3 volt, which is greater than 0.8 volt. So this one is in the, again in the saturation region. So like that we can find, but we have to know some basic idea. Okay, so for this value it is in the saturation region. Okay, so like that we can find the mode of operation for a NMOS. So for 3 volt it is coming, again it is coming saturation region. Okay, saturation region. So this is all about the this question. Okay, means how we have find out different mode of operation in which the threshold voltage is given 0, gate voltage is source terminal grounded and 1.4 applied to the gate, and source terminal is grounded. Okay, so in which region for different VD we can find. Okay, so we have already find for different VD. Okay, for VD 0.5 volt it is triode region, 0.9 volt saturation, and for 3 volt it is in the saturation region. This is all about this simple problem, and it is from the microelectronic circuits book. And this ID VDS characteristic is very important. We have to know these characteristics. Okay, so thank you for watching this video.